Slide 6 talks about algebra functions and combining functions. 2.6, combining functions. I will call this function also algebra of functions. What is algebra? What does algebra do? Well, all it does is adding, subtracting, multiplying, and dividing. But this time we're going to do it with functions. So assuming I'm given f and g, if I'm given these two functions, that I can create this function, I can create this function, I can create this function, and I can create this function. We do this in the previous class as well. So what does this mean, really? How do I read it, first of all? I read it like this. F plus g of x. How do I read this one? F minus g of x. F times g of x, and f over g of x. And it should be self-explanatory. What will the first function mean? Yes, f of x plus g of x. Perfect. What will the second function mean? Of course. Thank you. What will the third one mean? Of course. That's why we use that notation. If I tell you, here, I'm giving you f and g, create function t, then you will ask me how. But if I give you f and g and I say find f plus g of x, you will know how. Correct? Okay, what about the last one? F of x divided by g of x, and this one follows with an if. If what? Correct, of course, because we know the denominator cannot be 0 if g of x is not 0. However, there is a problem or potential problem. I may run into a problem and not be able to create these functions. When do you think I won't be able to create the sum difference product? At least those. The ratio is a little bit more different than the other ones. But when will be a problem in which I won't be able to create these two functions? These three functions. So here's the potential problem. Let's say this is f. And I'm going to say the domain is between -10 and 2. And let's say this is g. And I'm going to say is between 10 and 20. And I'm going to ask you find f plus g of 0. What would you write? By definition, you will write f of 0 plus. Okay, so then how much will this be? It does not exist. Why? F of 0 exists, right? It's right here. But what about g of 0? So, does not exist. Why? Because these two functions do not have what it's called what? What do you think? I'm missing a word here. What would you fit in there? What should the functions have? What type of domain should they have so that I can create the sum difference? Because if they don't exist at the same time, exactly, thank you, that's the word. Very good. If they don't have a piece, at least a tiny one, of a common domain, I can create the sum difference product ratio and so on and so forth. Okay, that's it. So now I'm coming back again and again and again and again to the same question of domain. So on page 196, let's find some domains. Find the domain of the function. Please choose 11 through 14. Choose a function, which we already did. We had few examples already, but let's choose another function. Which one? 13. Very good. So in problem 13 on page 196, we have f of x, which is, I'm sorry, it's h of x. You can write h of x. x minus 3 raised to negative 1/4. Good. We reviewed this a long time ago with those handouts. So I don't know what this is, but I know what to do to it. Yes, so it's 1 over to power. Perfect. What power, but when I tell you power 1/4 on something, what do you think of? Excellent, thank you very much. Now this looks much better. And what restriction would you write on x? Careful. So there are two things here. We have to notice that. First of all, there is a denominator. And secondly, there is a fourth root in the denominator. So double trouble. But not equal to. Because it's in the denominator. Exactly. So tell me what to write that is greater than 0. I have to write something and solve.
X minus 3 plus b.
That's it. That's it. I hope we can see this from now on. I know for some reason something is difficult with these radicals. Exactly. Yes. This quantity must be greater than or equal to 0, but now there is a problem since it's in the denominator. I cannot allow it to be 0. So greater than 3, so then the domain is 3 to infinity for this function. Very good. Assuming I have two functions, let's say f of x is x squared and g of x is x minus 3. What is the common domain of these two functions? So what is the domain of x squared? We already know the graph. We picture it as in our head. I know this for sure. This is the graph. The domain is? Good. I know how to graph this. I already know how to study its sign. It's already done. I know the domain. I see it with my eyes, and I don't even have to graph it. Good. So what will be the common domain of these two functions? That will also be the domain of all three top functions. So the common domain is always the domain of the sum, the difference, and the product. Always. So let's say, which one would you like to determine? Sum, difference, product. Okay, so you have fg of x. So by definition, this is f of x multiplied by g of x, which is x squared multiplied by x minus 3, which is x cubed minus 3x squared. Obviously, it has domain all real numbers. So now, I would like to ask you to find the domain of the ratio. Let's create the ratio. F of a g of x. Can anyone give us?
So x squared divided by x minus.
Yes, but I have to write the definition first. You're right. I completely agree. But please write the definition first so you don't make a mistake. And yes, it's x squared over x minus 3. I completely agree.
So
And now,
x cannot equal 3.
right. So then the domain of this function is not the common domain, but it's the common domain from which I must remove what?
3.
Yes. How do I write that?
Everything to 3 union.
Exactly. So that's the ratio, the domain of the ratio.
You also write this domain is x cannot equal 3. Or-
Yes, but we prefer to write the domain in interval notation.
Can you explain that again, please?
The denominator cannot be 0, x cannot be 3, so I have to exclude 3 from the domain.
And that's not that you're using the parentheses, not the brackets, right?
Right.
It's equal to.
Right. Yes, the parentheses, yes, does not include. Okay, I have 3 minutes. I just want to say one thing. There is a fifth way of determining functions, and that is called function composition. Last one. Fifth way of creating new functions if we are given two functions. And here it is. And here's the notation. And there are many combinations. I can have G, so how do I read it first? F comp G, or the composite of F and G, or G comp F, or the composite of G and F. Well, what does this mean? It does not mean addition, subtraction, multiplication, and division, for sure. What does it mean, though?
F of G of X.
Exactly. So F comp G of X means this is what it's called the inner function. And this is extremely important for those of you who move to calculus. And this is the outer function. The inner function will be G. It's the closest to X. I have to apply it first, and then I apply F to G. So the definition is F of G of X. Can anyone dictate the definition of the other one? Yes. Now here there is no need for a common domain. None whatsoever. Okay? Here is the idea. Totally different. Which function do we apply first in F comp G? G. So to this point, which is the domain of G, I apply G to get G of X. When I'm done and I got to this set, what function I apply next? To this number. So if I have 5, I apply G to 5, and let's say I get 10. To 10, I apply function F to get F of G of X. And of course, the order is reversed for the other one. So I apply F to X, I get F of X, and then I apply to F of X, I apply G, and I get G of F of X. As you notice, there's no need for common domain at all. But what could be the problem here? What could be the problem? So this set represents what for G? What is it called? Just a name. What is this set called for G? Of course, domain. What is this set called for G? Of course, it's the range. There are values of G right here, right? So X is the domain of G, and G is the range, right? What is this set for F? Exactly. So this must be also the domain, but of F. What if they don't work well together? That's the potential problem, and I leave you with that thought in mind, and we'll take it from here.